Greetings, AP Chemistry students. This is going to be a real short lesson for today. We're going to talk about the pH of strong acid solutions and also strong base solutions. And so what we do is we assume that strong acids and strong bases dissociate or ionize 100%, and that strong acid or base is the only source of either hydronium or hydroxide ions in solution. And the pH or pOH is directly related to the molarity of that acid or base. So we're going to consider a couple of examples. So first, it says, what is the pH of 1.45 molar HCl? Well, HCl will ionize to form H pluses and Cl minuses. If you wanted to set up an ice chart, this is 1.45. H plus and Cl minus essentially start at 0. Then it's going to go down by 1.45 to 0. So this goes up by 1.45 to 1.45, and this goes up by 1.45 to 1.45. So what I mean by it ionizes completely. 100% of it ionizes. You don't have any left over here on the reactant side. So your H plus concentration is 1.45, so the pH equals the negative log of 1.45. So we plug that into our trusty calculator. Negative log of 1.45 is negative 0.16. Which is interesting because the pH is negative and pH can be negative. What that would mean for the pOH is that the pOH would be 14.16 because you have to add those two together to equal 14. Right. So pH can go negative. That just means that you have a molarity that's of hydrogen ions that's greater than 1 molar. So this is a perfectly possible scenario to happen. The next example I want us to look at says, what is the pH if 12.5 grams of barium hydroxide is dissolved in 2 liters of solution? So first we need to figure out what the molarity of our solution is, which is moles over liters. We've got 2 liters. Now to find moles, we need to take 12.5 grams of barium hydroxide and turn those grams into moles. And the molar mass of barium hydroxide is 171.35. So that gives us 0.073 moles. We divide that by 2, and so that comes out to be 0.036 molarity. That's the molarity of the barium hydroxide. Now the hydroxide concentration will equal double that because barium hydroxide produces 2 hydroxides when it ionizes. So the hydroxide concentration is that 0.073 molar. So this kind of puts us back to where we started. So the pOH equals the negative log of 0.073, which is 1.14. The pH is 14 minus 1.14, which is 12.86. By the way, I do want to point out a quick thing about significant figures. Let's just say that this was 2.0 liters, so that this means our answer should have 2 significant figures. A weird thing about pH is the significant figures are only the numbers after the decimal points, because of when you take a logarithm, essentially the numbers before the decimal point represent the exponents in scientific notation. The numbers after the decimal are your significant figures. So that's just interesting thing I wanted to point out. So you should report these pHs here to 2 decimal points. That being said, you're going to have a little assignment for you to try, and I hope y'all have a great weekend.